All right, Helena, I'm recording our meeting now, even though I forgot to start it when I started talking. All right, so Helena, I'm going to make sure you watch the video. We just watched the video and I forgot to hit record. All right, so Helena, what we're talking about is cross section. So if you have a three-dimensional figure and you cut it, we're going to either cut it parallel to its base, so I'm cutting it this way, or I'm going to cut it perpendicular to its base, right? What does the word perpendicular mean? Two perpendicular lines form 90-degree angles, right? So when I say I'm going to cut it perpendicular to its base, I'm talking about a vertical cut. All right, so can you see these pictures? So look at the triangle, or it's not a triangle, it's a square-based pyramid, right? So here's a big hint, ladies. Are you ready for this huge hint? When you cut something parallel to its base, you get the same figure as whatever the base is. So what is the base of this pyramid right here? What is the shape of the base? It's a square, right? I even called it a square-based pyramid, right? So if you cut it perpendicular to its base, the cross section is a square. All right, what about this rectangular prism? It's being cut parallel to its base. So what's the cross section going to be? This one. It's also, yep, it's also a square, right? What about this pentagonal prism right here? I'm cutting it parallel to its base. So what's the cross section going to be? Yep, a pentagon, right? And then let's do the last parallel cut. What about the cylinder? If I cut it straight across, what's it going to give me? Straight across. It's going to be a circle. Now, when you're looking at a picture, be careful because there's a test question about this. And it says, what happens if I cut the cylinder parallel to its base? Well, when you look at the picture, it looks like an ellipse because we're looking at it. We're looking at a two-dimensional picture. Imagine a three-dimensional figure being cut. It may look like an ellipse or an oval, but if you really have a perfectly round cylinder and you cut it parallel to its base, it's going to be a circle, right? However, if I cut it at a diagonal, it is going to give me an ellipse or an oval. All right, now these two take a little bit more imagination. When you cut a figure perpendicular to its base, these pyramids can be tricky because based on where you actually cut them, you're going to get different figures. So if I cut it right down the center, what do you think the cross section is going to be of this square-based pyramid? Can you imagine? Yep, I'm seeing triangle. That's exactly right. Now, let me challenge, this is challenging. If I cut, so look at my pyramid. Let's see where my pencil or my mouse is. What if I came down the side and I cut it right here? Can you guys imagine? Can you imagine what shape, if I cut it straight down right here? Can you imagine what you're going to see? It's hard to see in your brain, but anybody have any guesses? Ella, how are you so smart? Any other girls have a guess? Naomi, Allie, you have a guess? It's going to be a trapezoid. Oh my goodness. Oh my goodness. My drawing skills, guys. I need to go to art school just to draw a trapezoid. How can that be so bad? Yes, anyway, it's a trapezoid. One more time, just for fun. No, I can't do it. It's pen. All right, so what about the rectangular prism? If I cut it this way, parallel to its base, or perpendicular to its base, yep, we're gonna see a rectangle, right? All right, y'all understand? Any questions on that? Good. All right, we've already answered those questions. What are the cross sections? Which 3D figures are being slid? It should say sliced. Which 3D figures are being sliced perpendicular to their bases? How many? I'll answer that. I'll ask that question. How many of these figures are being sliced perpendicular to their bases? Out of 6, how many are being cut perpendicular to their bases? It's those 2, correct? It's these 2. Good. All right, and then we talked about the cross sections. Oh, and that's what I was trying to get you to imagine. So coming down this pyramid, if we cut it right here straight down, do you guys see that two-dimensional two-dimensional trapezoid right there? And then this one shows the triangle right down the center. And of course, this one shows the square if you cut it parallel to its base. Good, Naomi. Yeah, it's hard for me to imagine too, but I think this picture shows us the trapezoid. All right, we're moving on, ladies. All right, so, and that's all I had about cross sections. Y'all good? Are y'all gonna get the question right about the cylinder if I cut it parallel to its base? I keep losing my pen. Why isn't my pen working? Hold on, my pen is acting crazy. 1 second. All right, so if I give you a cylinder, stop it. They brought us new mouses today. Can I say that? Do I have to say mice even if it's a computer mouse? And I think it's, look at this. I can't even draw a straight line, you guys. And I think it's, oh my gosh. Okay, so pretend that's a beautiful cylinder. And if I say I'm going to cut it this way, well, if I drew a picture, because of the way the picture looks, it looks like it would be an oval, right? But if I was really holding a round cylinder like my coffee cup, isn't the base going to be a circle? So on a test, if it shows you pictures, what is the cross section? And one of the pictures is a rectangle. We're not going to choose that one. Let's say that's choice A. Let's say choice B is an ellipse. And let's say choice C is a perfect, beautiful circle that I can't draw, but pretend that's a perfect circle. What choice are you going to pick, girls? You're going to pick C, even though it looks, even though it looks like an ellipse, right? It isn't, it's a circle because we are looking at a two-dimensional surface trying to represent a three-dimensional figure, okay? Am I making any sense at all? Okay, good. All right, so I'm going to get out of here. All right, so what we're going to do is practice finding the area of triangles. Have you guys found the area of triangles before? Have y'all done that before? Did y'all do it last year in 6th grade? Okay, good. Well, then this is just a review. So basically the thing you want to look for as far as the height of a triangle is you always have to find a 90-degree angle. So a lot of triangles are drawn like this so that there isn't a 90-degree angle as part of the triangle. But if you have to find the area, they're always going to give you that imaginary line and say, hey guys, actually the height is 14 because this diagonal line might actually be 16. But if you say the height is 16, that's not right. You have to find a right angle for the height. Always, always, always. Okay. So let's just use our little handy dandy calculators. All we're going to do is multiply our base times our heights, and we're going to divide by 2. So you guys, please find the area of these triangles. Send me your answers. Good. Good, Allie. Allie, there's 2 of them, though.
If any staff member has not picked up their Chick-fil-A box, please go to the
Good, Ella.
stand at this time.
Good, Allie. Yes, Naomi. Beautiful. All right, y'all got that. They're 21 and 59.5. Absolutely. That's exactly right. All right, now last year in 6th grade, I believe when y'all did trapezoids last year, they said, all right, girls, look at this. We have 2 triangles and a rectangle, right? So last year in 6th grade, to find the area of a trapezoid, they would ask you, oh my gosh, what is wrong with me? I think last year they would ask you to find the area of this triangle, the area of this triangle, and the area of this rectangle and add it all together, right? Isn't that what you did last year? Well, this year we're not doing it that way. We're going to use this formula. So this is the formula on finding the area of a trapezoid. So all trapezoids have 2 bases, and the bases are always the parallel sides. So the 2 sides that are parallel to each other are the bases. So sometimes, look at the screen here. I don't know why I'm trying to draw, but I'm going to again. So sometimes a trapezoid will look like this, okay? And so this and this are our parallel sides. Okay, so it's not always the top and bottom. Sometimes it's the 2 sides that are parallel. So basically what you do is you add together those 2 parallel sides. So we're going to add together 12 plus 7. And then you always divide the sum of the bases by 2. And then we multiply by the height. And remember, once again, the height is always forming a right angle, always. So if they give you this slanted line over here, if they say this is 4, since that line right here doesn't form a 90-degree angle with anything else, you can't use 4, you have to use 3. Do you understand what I'm saying? Okay, so half of 19 times 3 is, whoops, I messed up. 28.5. Yes, 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 Ella. Yes, Naomi. All right, everybody good with that one? I should have given y'all at least 2 to try, did I not? Nope, that's just a rectangle. What's the area of this rectangle, everyone? Mm-hmm. It's just the base times the height, right? Or length times width, whatever you want to say. Dang, I should have given you one more. Let me give you one more. All right, let's pretend I can draw a straight line. Oh my gosh. All right, so pretend this is my trapezoid, right? Here's my 90-degree angle. These lines are supposed to be parallel. All right, so let's say my dimensions are, I want you to find, we have 11, 10, 8, and 7. I want you to find the area of this trapezoid. That's not right, Ella. Allie, that's not right, sweetie. Look at your formula, guys. You're adding your bases together. You're dividing by 2, and you're multiplying by the height. Remember, you're looking for that 90-degree angle for your height. Naomi, that's not right, sweetie. Oh my gosh, Allie, you're so close. You're so close, Allie. Funny, Allie. Funny. Yes. You guessed one of the right answers. Don't guess. Look at it. How am I going to get one of those answers? All right. You want me to tell you or you want to figure it out? Try it one more time. Okay. Good, Allie. Yes, Ella. All right, Naomi, are you going to guess? Or are you almost done? Fingers are broken. No, do this. Yeah, see, you're good. Naomi, do you know? Am I rushing you? Okay, it's all right. All right, so what did I say about the bases? How do we know what the bases are? There's 4 numbers. How in the world am I supposed to know what the bases of a trapezoid are? We're looking for the 2 parallel lines, right, girls? So pretend, like I said, pretend these are straight. Aren't these parallel, these 2? So the parallel sides are the bases. So base 1 plus base 2 divided by 2. So I see 18 divided by 2, which is 9. And now how do I know what the height is? Is the height 11 or is the height 7? How am I supposed to figure out what the height is? What am I looking for? The height is not 11 because remember the height, look right here, you're looking for a 90-degree angle. Does this line right here form a 90-degree angle with another side? No, but doesn't this 7 form a 90-degree angle with one of my bases? That's why I have to use 7, okay? So half of 18 times 7 is 63. So the area is 63. Does that help to go over that? Can I give you one more just to double check and make sure we all got it? Can we do one more? All right, I'm gonna make up another one. Let me do this. Okay, that's kind of looks like an actual real trapezoid kind of. All right, let me do, that's supposed to be those dotted lines. That's a 4. Whoops, that's a 4. This is, oh my gosh, this is a 12, 8, and 5. Find the area of this trapezoid. Allie, no. Ella, yes. Good. Yep. Good, Allie. All right, Naomi, any guesses? We have to move on. I'm sorry. Yay, Naomi, you all got it. Good, 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 good. So our bases are 12 and 8, right? So half of our base is 10. And then we know our height is 4 because 4 makes this 90-degree angle with one of the bases. Okay? Excellent, ladies. All right, we're moving on to three-dimensional figures now. So when you find the surface area, that means you have to find the area of all of the sides and add them all together, okay? How many sides does a rectangular prism have? If you're holding a cereal box in your hand, a cereal box, how many sides does it have? 6, yep. 6. So this is what I do. This is what I do. When I'm doing the area of a three-dimensional figure, this is my own code to myself. I say, wait, hold on. Let me go back. Sorry. Stupid mouse. I'm sorry. I shouldn't say stupid. This is what I say. I do a little code over here on the side. I do top, bottom, side, side, front, back. I make myself a little cheat sheet over here. So I make sure I have added together 6 numbers. Do you see what I'm saying? All right, so what's the dimension of the top of my box right here? What's the dimensions of my box? What's the length and the width, or the 4 and 5, right? The top and bottom are both 4 by 5. So what is the area of the top and bottom? $20. So the top is 20 and the bottom's 20. Okay. All right, that takes care of 2 of them. Now I'm going to do the side and side. So let me change colors. What is the dimensions of my sides? How tall and wide are my sides? What are the dimension of my sides? 5 by 10, right? And there's 2 of them. So I'm going to do 50 plus 50. Those are my sides. And then finally, I have a front and back. What are the dimensions of my front of my box and the back of my box? 40, exactly right. So the front and back are the same, the 2 sides are the same, and the top and bottom are the same. So then once I have my 6 numbers, all I got to do is add them all up. And I think it's 220. Yep. Allie agreed with me. No, not Allie. Ella, sorry. So if this code thing helps you, then go ahead and write it on your paper and do it, okay? All right, now let's look at this triangular prism. How many sides does this triangular prism have? 5. So I'm going to do front, back, because my front and back are pyramids. No, they're not. They're triangles, right? And then I have 3 sides. Sometimes my sides are the same, but a lot of times they're not. So the tricky part, girls, is the side. So make sure when you're doing the triangles, once again, we're looking for a 90-degree angle. So for the triangle, are we going to use 5 for the height or 4 for the height? Good. All right, so what is the area of my triangle, my front and back? What's the area of my triangles? So together they're 24, but they're both really 12, aren't they? Don't forget to divide by 2 for a triangle, right? The front's 12 and the back's 12. All right, so let's look at the bottom of the triangle of the prism. The bottom. What is the dimensions of the bottom of my prism? What's the area of the bottom of my prism? Good, Ella. Allie, don't stop. Don't leave us. Don't leave us, Allie. The bottom is 48. What about the two sides? In this situation, the two sides are congruent. Good, Naomi. What's the area of my sides? Right, and I have two of them, right? So I got to make sure I add my 5 numbers together and then tell me what the surface area of the whole thing is, guys. Allie, you're right. Ella, something happened. Oh no. Ella, I think you forgot to divide your triangles by 2, right? Did you do that? I don't know. Yep, good, Naomi. So when I added these together, I got 152. Ella's trying it one more time. Hi, Allie's brother. He was looking at me. Can he hear me? Did you get it? He can't hear me. Oh. Did you get it, Ella, Ella, Ella? You want me to move on? Leave you alone, Ella? Want me to move on? Oh, you got it. Awesome, awesome. All right, I'm going to be quiet, ladies, and I want y'all to find the area of this triangular prism on the bottom. All right. Did you get it, Allie, Allie? The 3 of us got... Oh, she's still savage. Well, we got to go, Allie. I'm so sorry. We got to keep going. Got to keep going. But it's Oh, she really wants to answer it. Right, Allie? You really want to answer it. All right. So Naomi and Ella, find the surface area of that cube, please. Allie, that one was, are you doing the one on the bottom, Allie? You can unmute, silly Willy.
I solved the one below the question, the 10, 4, and 5.
10, 4, and 5. No, we've already done that one, Goofy.
And
We're doing the bottom one. All right, so anyway, yeah, the next page is the last. Yes. All right, so the one on the bottom is 204, okay? This one's 204, but we have to move on because we have like 2 minutes. All right, now cubes are pretty easy. So because all the sides are the same, so basically we're doing 7 times 7, which is 49. So all 6 sides are 49, right? So we're just multiplying 49 times 6, and the cube is 294. All right, but I do want to talk about the last page real quick. So prisms, as far as finding the volume, so volume is how much something holds, right? So for prisms, you just multiply the base times the width times the height. Okay, so these first two are, well, they're all prisms. I should be more specific. When we have rectangular prisms or cubes, we just multiply the base times the width times the height, right? But when we have a triangular prism, that capital B means the area of the base. So remember how you find the area of a triangle? So for triangular prisms, you're going to multiply 7 times 24, but then don't forget you have to half it. And then you multiply by the height of the prism. Does that make sense? So that capital B means the area of the base. All right, so y'all do those 3 super duper 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 fast. Out of time. All right, so look at my answers on the screen. All right, let's look at the last 2 questions, ladies. I'm sorry, I'm rushing you, but you're going to have a question like these on your next test, okay? Are y'all looking at the screen? All right, so both of these questions, both of these problems go ahead and give you the volume. They both do. Both of them give you the volume, and they're looking for one of the dimensions. So this one's asking for the height, and this one's asking for the depth, right? So if the volume is 3024 and the area of the base is 168, remember that's capital B, and I don't know the height, how am I going to solve this equation? What am I going to do to solve for H? Exactly. I am dividing. Yep. So the height, when I divide, I get the height is about 18. All right, Allie and Naomi, look at that problem. Make sure that makes sense to you. Okay, now the bottom one, it doesn't give me the area of the base, but it does tell me the length and the width. So what am I going to do on the bottom one? So I'm going to multiply 30 and 15. I get 450. I don't know the depth. So what's my last step? What am I going to do? Good, Ella. Yep. So on the last one, I'm also dividing. I'm dividing 2250 by 450. And my answer is, that's my drum roll. 5. Good. I know. Don't be a drummer, Miss Richardson. All right, girls. I'm sorry I kept you. I'm sorry I kept you so long, but I adore you guys. Y'all have a great rest of your day. I'll see you next week.
Bye. My calculator almost went. My calculator was like, while she's putting her arm down, let's go fly off the desk.
Oh, I like, what an interesting calculator. Y'all tell Helena bye. She's watching our recording. Bye, Helena. Bye. Bye, girls.